All right, that car crash video, I think it's pretty cool. They actually updated it to some HD, so I thought it was some pretty cool stuff, pretty applicable. This concept of impulse is pretty fantastic. You can think of it when you're golfing, you can think of it when you're playing hockey, you can think of it when you're driving your car, throwing eggs or water balloons, really receiving the egg, receiving the water balloon, any type of fight. Impulse is this concept that there's a force applied over a period of time to change the momentum. Okay, if you remember that in the previous video, momentum, right? Momentum equals mass times velocity. Okay, so change in momentum, right, is mass. The mass doesn't change, so if a baseball's coming in, it doesn't change mass, it might get deformed. Right? It doesn't change mass, but it does change velocity. It might be coming in, right? It might be coming in at 90 miles an hour, right? So it might be coming in at 90 miles an hour. Right now, I need to be in the right units, but it might leave at what, 150? But the direction is, if this is positive, right? If this direction in is positive, then this direction out would be a negative 150, so you get this basically additive effect of 240 is that change in momentum. Okay, so if it gets something to change direction, you've got a greater amount of momentum change. So again, momentum, mass times velocity, change in momentum is mass times the change in velocity. Can't change the mass of the object, don't want to do that. I want to change the velocity of the object. So if it's directional, right, one coming in, going out, right, velocity has direction, so one's positive, one's negative, and the difference will add up. If it's going the same direction and gets another boost, they're both in, say, the positive direction, they'll subtract from each other, okay? It's about that difference in velocity. So remember, this is, on this side, of course, I don't know why I keep those pens. This side is the change in momentum. So a force applied over time changes the momentum of something. If I can quantify how much momentum has changed, I know the impulse, right? They don't really have a letter for force times time. There's no letter for impulse. So if I know the impulse, I can calculate the change in momentum. If I know the change in momentum, I can find the impulse, okay? So you're going to be in an activity where they might have a change in velocity, right? That might be the difference between two things. Mass, I'm not sure how they do that, but maybe they change, I don't think they can change the mass, but maybe there's a situation where they change the mass, okay? That would change the momentum, right, between the two objects. Maybe if they change the time at which the force is applied, right? And you remember in that, if the change of momentum is the same, I go from 55 mile an hour to 0, so the change of momentum is the same. If I increase the time, my force, if I increase the time, the force has to go down to keep the change of momentum the same. Or if the momentum is the same and I increase the force or I decrease the time, the force has to go up. And that was in that car crash. The car crashes, they're trying to increase the time, right, by having that crumple zone so that their force will be reduced. And if my time is really short, that force will be super high, okay? That could even be the egg demo, right? The time at which the egg crushed or was stopped was immediate. Short time, large force crushed the egg. But you do it on a towel or a blanket if you can hit it, right? I've had students miss it. We were also going to do that in class. If I increase the time that the egg stops, my force is reduced because it started at maybe 30 miles an hour to 0 by stopping in the towel or sheet, or it hit the wall from 30 miles an hour to 0 and it cracked because the force was too large. So let me get to my screen and show you the physics classroom activity that I have for you, and hopefully we can work this out. And it's called Case Studies for Impulse and Force. Now I want you to know there's 4 questions in Master, and there are 8 questions for Wizard. I am offering 10 extra credit points, meaning it's worth 10 points if you do the 4 questions, but you could get 20 out of 10 if you do the Wizard, okay? I'm going to go to Wizard just to see what they got, okay? This is that egg, okay? So let's just talk about what they've got in relation to this. Jumbo egg is released from 1 meter high, and it falls to the ground and stops. The same jumbo egg is released from 5 meters high, and it falls to the ground and stops. The collision time is the same for each, right? So which variable is different for these 2 eggs? If I go to this, is the force different? Well, it's the same egg, same mass, so the force of gravity is the same. The time it cracks is the same. The mass of the egg is the same, but the velocity is different. When I drop it from a higher height, right, it has more stored energy. By the time it reaches the ground, it's going faster. So my momentum change is quite different in that scenario. Okay, so I've got a larger, right? So is it delta V? Is it time? Is it mass? Right? Neither. It's delta V. It changes velocity. That's what's different between the cases. Which case involves the greatest momentum change? One goes from a faster velocity, right? B goes from a faster velocity to 0 velocity. So B is that change. Which case involves the greatest impulse? Let's remember this formula. Impulse is equal to the change in momentum. So which one has the greater change in momentum? That would have the greater impulse, right? This side is equal to that side. This side equals change in momentum. This side is the impulse. So if I go back, which case involves the greatest impulse? Well, the one with the greatest momentum change. And which case involves the greater force? Well, since they have the same, one has a greater momentum and they have the same time, it has to be object B. Okay? Both the same. So that's another option, just so you know. A, B, both the same. Go back. Both the same, A, B, both the same. Okay, let's see how I did. That way. Sometimes I sweat on these, okay? I'd have to redo that whole video. Okay, so that's what you're looking at. Different cases of momentum change between case A, one car going 18. Oh, they're both going, right, at 18 meters per second. One bounces backwards with a speed of 6 meters per second. The other one crumples and stops. So that's going to be what, right? What differs? Their speed's the same, mass is the same, right? But I have a recoil speed, so that's a little interesting. Okay, so their initial speed and their final speed is quite different. Okay, so that's why that's the wizard section. So I wanted to do this overview video so you could see that. I know it's a lot of videos. It's probably about 20 minutes of videos prior to getting into your activity. I'm still going to keep it for one day and see how we do. Okay, talk to you later.